Yes, sir.
Macroscopic properties. Okay. Now, macroscopic properties can be divided into two different types. Please write macroscopic properties. These are divided into two types. One is known as, there are some things which depend on mass. There are things that do not depend on mass, right? Things that depend on mass. For example, if I talk about the number of moles, अगर आप number of moles को ज्यादा करना चाहेंगे तो mass भी ज्यादा हो जाएगा, right? So it depends on mass. If you take more water molecules, the number of moles will be also higher. The mass will also be higher, but the density is not going to change. But the density is not going to change. If I have a bucket of water like this, and this bucket of water, ये पूरा पानी है यहाँ पे, this bucket of water is having, let us suppose, 25 degrees Celsius temperature. Now, even if I take a small amount of water, that is going to be also 25 degrees Celsius. And so, for example, here temperature is also what? It is also a property that does not depend on mass. The property, a microscopic property that does not depend on mass. So there are properties which depend on mass, which are known as extensive property. ठीक है, जिसको एक्सटेंड किया जा सकता है. आप मास बढ़ाइए तो वो प्रॉपर्टी बढ़ने लगेगी, है ना? जैसे मान लीजिए, if you increase the mass of water, then the volume will also increase, the number of moles will also increase. Okay, so these depend on the mass or amount of substance. Then we have intensive properties. Doesn't depend on the mass or amount of substance. Or amount of substance. The question. Classify the following as extensive and intensive. And guys, please try to come on time, guys. I wait 5 minutes and I start the class. Still people are late. Take a screenshot of the above case. I started with macroscopic properties. Macroscopic properties are the bulk properties. When we talk about matter, for example, water we took as an example. If I talk about water, water is going to have such much, that much bond angle, that much bond strength, that much bond energy, and water will have bent shape. All of these are microscopic properties of water. When we talk about macroscopic property, that means the bulk property of water. If I take a bucket of water, we are not going to talk about the bond angle there. We're going to talk about the temperature, the volume, the number of moles of water that is present there. So these are known as the bulk properties, and those are the macroscopic properties. And in this chapter, thermodynamics, we'll be dealing with macroscopic properties only. Macroscopic properties are divided into two categories. Some property, they depend on mass or the amount of substance. For example, if you take a glass of water and if you take a bucket of water, so the bucket of water is going to have more number of moles. It is going to have a higher volume, right? But if you're taking both the water from the same container, then the temperature with both of them will be same. The glass one and the bucket one. Similarly, the density of water is going to same, right? So these things do not depend on mass. Extensive means if you increase the mass, the property will also extend, it will also increase. And intensive means if you increase or decrease the mass, it does not depend on those things. Okay, so those are independent of mass of the substance or the amount of the substance. Is anyone still writing this? Yes or no? Please tell me. Anyone still writing it? No. Now, right next, classify the following as extensive and intensive. Write the A part, mass. Write B, volume. Density. Number of moles. Temperature. Boiling point. Melting point. And pressure. प्रेशर का 2 केस लेंगे. Pressure in flexible boundary and in rigid boundary. Pressure in the sense of pressure of gas. Pressure of gas. Write this question down. I'm giving you answer how to write the answer. You write A, mass. It is going to be what? Extensive. So you just write E. ठीक है, आप आंसर में बस E लिख दीजिए और जहां पे इंटेंसिव है वहां पे I लिख दीजिए. So this will be extensive. Okay, and send the answers on chat also. I'll give you like 5 minutes. Please send the answers. Got 2 answers here. Yusuf, can you please just send me one message rather than 9 messages? Try to send in one text. आप बस ऐसे लिख सकते हैं A, E, B, E, and so on. If anyone wants, they can write the answer, send the answer on WhatsApp also. Just give me a second. Pressure, we have two cases, Farhan. We have pressure in extensive as well as, pressure in flexible and rigid boundary. Okay, Iram and Hiba, you have sent answers on WhatsApp. Extensive. Okay. So, ABC, mass, extensive, density, intensive, extensive, flexible boundary, extensive. Yeah. Iram, very good. That is correct. Yes. Okay. See here, guys. Volume, it is obviously going to be extensive. Density is going to be intensive. Number of moles, obviously extensive, because if I increase, then it is going to increase. Temperature is going to be intensive, no matter if you take small mass or greater mass. If you're taking from the same substance, it is going to be intensive. Boiling point of water doesn't matter if you have 2 moles or 10 moles, 2 liters or 10 liters, it is going to be still 100 degrees Celsius. It is going to be intensive. Melting point also intensive. Now, let us talk about pressure here. Let us talk about pressure here. In pressure, we have two cases. If I have a flexible boundary, that means there is a piston and this piston can move. Now, if I add more number of moles, what is going to happen? This piston is going to move above, right? And in this case of flexible boundary, if you add more volume of gas, this is going to be extensive. No, sorry. If you have flexible boundary, wait a second. My bad. If we have a piston here, that is lying like this, and we have some pressure here. We have some number of moles, and there is some pressure, right? So obviously, pressure will be directly proportional to the number of moles. If I add more pressure, keeping everything same, then that is going to give it a huge pressure here. But if I add more number of moles, and this is a flexible boundary, this flexible boundary will move up, giving rise to what? More volume. And if you have the same, if you have a large amount of gas, and there is an increase in number of moles, so in that case also the pressure will remain same, because now the molecules of gas, they have got a larger area to move around. Okay, so the pressure remains same if you have a flexible boundary. So this is going to be intensive. Okay, but if you have a rigid boundary like this, and you input more number of moles of gases, so these number of moles of gases, they are not getting enough volume to move around, and that is why it is going to be extensive if you have rigid boundary. But if they have given you just pressure and not given you anything, then you will assume that it is a flexible boundary. Okay, you will assume that it is a flexible boundary. Same is the case of temperature. Temperature is going to be intensive only if you have a flexible boundary, and generally you will have a flexible boundary only. Rigid boundaries, they will give you that it is going to be rigid. Okay, so if you have been given just pressure, assume it is a flexible boundary and the property is going to be intensive. Please write this down. I hope everyone is done. If you have any doubt in any one of these properties, please let me know. If nothing, then we can move on. Okay. So now we have defined all the necessary terms. Okay. There are a few terms more that we are going to define. But before that, what are we going to study in this particular chapter? We're going to study in chemistry, we talk about matter, or we talk about the change of matter, and that with that aspect, we have also the energy consumption. So there is an initial phase, and then there is some process happens. Okay, there is some process that is happening. And with this process, there is some change that is happening. And then we get the final, the product or the final system. So we have initial conditions and then we have the final system. Now, in this chapter, we are going to learn about the process and the change that it brings. Okay, and the change that is happening. So we are only dealing with this thing here. That is, what is the change that is happening? In the chapter of equilibrium, we will talk about this final state where nothing happens. Once you achieve when the change stops, we say that equilibrium has been achieved. Okay, when we don't see any change in the macroscopic properties, for example, some reaction happens. Okay, some reaction is happening, and then you are monitoring that reaction with the change in temperature. Then you will say, okay, fine, the temperature is increasing, and now it stops. So now we have achieved equilibrium at that point. When macroscopic properties, they do not change. For example, if you have two blocks of iron, this is block A, which is 100 degrees Celsius, and this is block B, which is 0 degrees Celsius. Both are of the same size. This is 0 degrees Celsius. What is going to happen if I am going to bring them together? If I have A and B blocks of iron, and both of them are touching each other now. So what is going to happen? Tell me. I say that the temperature of block A is going to decrease and the temperature of block B is going to increase. This is the first option. Second option is nothing happens. If you bring them together and both of them are touching each other, still there is no change. A and B are as it is. Or the third case, if I bring them together, the temperature of A is going to increase and the temperature of B is going to decrease. Tell me, what do you think? Or write the fourth option, don't know. Which option is correct? I want answers from everyone. Na? Ab ye sare answer, I expect these answers, okay? I expect these answers at least. 1, 2, 3, 4 option है हेबा. A तो option ही नहीं है. देवांगी A तो option ही नहीं है. क्या आपको लिखते हैं? हाँ. 1, 2, 3 और 4. Yes. What about others? Iram, Jania, Tarif, Waziha, Yusuf. Please answer, guys. What is going to happen if I bring them together? The temperature, this increase and decrease of temperature is written, okay? The temperature of A will decrease and the temperature of B will increase, or nothing happens, or the opposite, A increases and B decreases. The answer देख के answer कीजिए. I will wait 1 more minute. Okay. So I hope you all answered using your brains, and all of you have answered correctly that this is going to happen, right? As we touch each other, what is going to happen? The temperature of A is going to decrease and the temperature of B is going to increase. And slowly, what is going to happen? They will achieve the equilibrium that the whole block A and B, they will become somewhere around 50 degrees Celsius. We don't know, somewhere around, but 50 degrees Celsius they will. If we have created a vacuum over here, we don't have any surrounding temperature. And A has only one surrounding, that is B, and B has only one surrounding, that is A. In that particular isolated and ideal condition, we will achieve 50 degrees Celsius. Otherwise, अगर आप इसको और थोड़ी देर के लिए छोड़ देंगे, then and you have a room temperature here which is of 25 degrees Celsius, then it will come down to 25 degrees Celsius also, okay, or somewhere around that, not exactly, but if somewhere around that, because जो air के heat capacity और iron की heat capacity, they are going to be different, but we can say that it is going to achieve 25 degrees Celsius if it is kept in room. But if I have only A and B, then it will achieve 50 degrees Celsius, and nothing is going to happen from right now. Now we are more interested in this part, that हो क्या रहा है, A का decrease हो रहा है, B का increase हो रहा है, not this part which is the equilibrium. After this there is no change, so that is the equilibrium that we'll deal in the next chapter. There is no Obviously there will be some things going around. यहाँ पे छोटे छोटे molecules जो microscopic properties है ना, this movements will be having some higher temperature, some lower temperature here and there, but at all overall macroscopic bulk property, that is temperature of the overall block of iron, it is going to be 50 degrees Celsius. That is why we will say that it has achieved equilibrium. Okay, yeah, it has achieved equilibrium. Now there are few things that can change with time. There are few things that can change with time. Here what was changing? Here the temperature was changing, right? What else can change? There can be concentration which can change. What else can change? The pressure of the, if you have a gaseous chamber, the pressure is going to change. So all of these properties that we can monitor, right? Which we can monitor, these are known as state variables. These are known as state variables. Please write the first point, state variables. State variables. Please write those properties that define the state of system are called state variables. ठीक है, are called state variables. ठीक है, फॉर एग्जाम्पल देखिए स्टेट वेरिएबल्स आप लोगों को लग रहा होगा कि वो प्रॉपर्टीज वही ना, वही मैक्रोस्कोपिक प्रॉपर्टीज. ठीक है, बट in order to define a system we don't need all the macroscopic properties. एक एग्जांपल से आपको हम समझाते हैं. फॉर एग्जांपल यू हैव अ कप ऑफ कॉफी और टी. लेट अस टेक टी. आपके पास एक गरम चाय की प्याली है ना. यू हैव अ कप ऑफ टी हियर. नाउ you have a cup of tea, okay, and let us suppose it is having, I don't know what temperature is ideal, but 60 degrees Celsius, let us take, okay, and it is 2500 ml. अब इसमें हम दो केसेस लेते हैं आपके पास. एक केस है जब आपने काफी टाइम तक इसको छोड़ दिया, आप भूल गए चाय के बारे में, और आप लगभग after 20 minutes you return to your room and you get the same amount of coffee here, right? You get the same amount of coffee, but this coffee will be having room temperature now, right? This will be having 25 degrees Celsius and कुछ ज्यादा नहीं होगा, 250 ml कर देते हैं ना, 2.5 लीटर हो जाता नहीं तो 250 ml. Okay, that has not changed. But let us suppose there is another case in which आपने ज्यादा टाइम नहीं बिताया आपने इधर. You just went out for 1 minute and you came back to your room, and what do you see? You see that the amount has decreased. You see that the amount has decreased here. Okay, let us say that it is just now. The temperature will be same, 60 degrees Celsius, and it will be now what? It will be like 25 ml. ठीक है. अब बताइए इन दोनों सिनेरियो का जो रिजल्ट होगा that will be different, right? In the first case, what you are going to do, you are going to go back to the kitchen and you are going to heat it up. If you can heat it up and then you want to drink it, then you can, or you are going to make a new cup of tea. But in the second case, what you are going to do, आप अपने भाई बहन को ढूंढने जाइएगा कि कौन पी गया, right? So both of these things are different situations here. Both of these things are different situations, and we will use different variables in order to define. If we have the first scenario, then only temperature is sufficient in order to define the state. है ना? And here the state variable is going to be what? State variable is going to be only temperature. Doesn't matter what ml of tea you are having. But in the second case, if I talk about, in the second case, what is important? The state variable that is here is this temperature. We don't need the temperature property to define this state, because for us, state variables you are going to choose. You're going to choose the state variable in order to define the system. Okay. You, that means the questioner, or you, or the system that you are dealing with. Okay. So the macroscopic properties, उसी में से कुछ को हम choose करेंगे, and then we will define the state variables. Is this clear? Yes or no? Please tell me, guys. The macroscopic properties or state variables में क्या difference है? Yes or no? Tell me. Is this clear?
Yes.
है ना? ओके, सो ऑलवेज रिमेंबर, ऐसा कंफ्यूज मत होइएगा कि मैक्रोस्कोपिक प्रॉपर्टीज और स्टेट वेरिएबल्स में डिफरेंस क्या है। डिफरेंस ये है, स्टेट वेरिएबल्स आप चूज करेंगे या फिर जो आदमी सिस्टम में काम कर रहा है वो चूज करेगा। मैक्रोस्कोपिक प्रॉपर्टीज किसने डिफाइन की है? मैक्रोस्कोपिक प्रॉपर्टीज इज डिफाइंड बाय द सब्जेक्ट, ठीक है। सो इट इज डिफाइंड बाय द सब्जेक्ट की टेम्परेचर है। अब टेम्परेचर आप लेंगे या नहीं लेंगे वो आप डिसाइड कीजिए स्टेट वेरिएबल्स के अकॉर्डिंग। ओके, वी विल डिफाइन इट अकॉर्डिंग टू द स्टेट वेरिएबल। नाउ there's another thing. All of these state variables, some of it depends on what path you have taken to go through the change, and some of it they do not depend. So those are those things which only depend on the state. Is that there are two types of state variables. Some are known as state function. Some variables are state function. This depends only on the initial and final state of system. Then there are some path functions. These are the variables which depend on the way in which process was carried out. Please write this down. All of you done use some of these me? All of you wrote this? State function and path function. अब धीरे धीरे ना हम लोग जिस तरह से प्रोसेस, वी विल बी डिफाइनिंग डिफरेंट प्रोसेस, और उस प्रोसेस से फिर हम लोग डिफाइन करेंगे कि यहाँ पे जो आपके पास प्रॉपर्टी है दैट इज गोइंग टू बी स्टेट फंक्शन या पाथ फंक्शन। ओके, सो प्लीज राइट फर्स्ट ऑफ ऑल थर्मोडायनामिक प्रोसेस। राइट द टॉपिक थर्मोडायनामिक प्रोसेस। अच्छा, प्रोसेस क्या होता है तो जनरली लिख लीजिए, प्रोसेस results in change of at least one state variable. जब अगर स्टेट वेरिएबल सारे के सारे सेम हैं, then we will say that there is no process that has taken place. Number A, isothermal process. Isothermal. Important thing about this is the temperature is constant in this process. Temperature remains constant. Write the B1. Adiabatic. Right here. No exchange of heat has taken place. No exchange of heat. That means you have neither given heat nor taken heat. Heat could generally be show as small q, and this will be equal to 0. Write the C part. Isobaric process. In isobaric process, the pressure is constant. Pressure remains constant. D is isochoric process. In isochoric process, volume is constant. Volume remains constant. E part is your cyclic process. In this case, in cyclic process, what is going to happen? After मतलब सारे प्रोसेस जितने भी हो जाएंगे ना, उसके बाद आपके पास मेन इनिशियल स्टेट में चला जाएगा. ओके, द सिस्टम विल गो टू द इनिशियल स्टेट आफ्टर various process. System returns to initial state. इसके बाद एक आता है रिवर्सिबल प्रोसेस एंड इररिवर्सिबल प्रोसेस. ठीक है. And to understand what is reversible process and what is irreversible process, we are going to take an example. Okay. First of all, write all of these 5 processes. I'll give you 20-30 seconds, and then you will understand what is reversible and what is irreversible. All of you done? See, please don't write anything. Let us suppose you have a container like this, and this container, please don't write anything. This container here, it has a piston. And it is a movable piston. Okay, it is a movable piston. And also we have here sand. What do we have? We have here sand. It is not going to get small. We also have sand with us. Now what we need to do? We have to change the system from this state to this state. Okay, how can it be done? We can do this by pouring the sand here. We can pour all the sand here like this, and if you pour all the sand here, what is going to happen? The piston is going to move downwards, right? Okay, the piston is going to move downwards. यहाँ तक clear है सबको? Yes or no? Please tell me, guys. Yes or no? ठीक है. अब इसी चीज को करने के ना दो तरीके. How can you do? आप पूरा बोरा लीजिए एक बार, you take it once and then pour the complete thing. Then you go directly in that case. ठीक है, आप सीधा क्या चल जाएंगे? Initial से final state. Now there is a very time-taking process, but that is also possible. It is not impossible. What you do? You take 1 grain of sand. Okay. What you do? You take 1 grain of sand and you go small way like this. Okay. You put 1 grain of sand. Then you put another grain of sand. You put another grain of sand. Slowly, slowly, one grain of sand, and slowly, 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 slowly. What will happen? You will reach this. Yes or no? Please tell me, guys. There are two ways in which we can do this. Yes or no?
Yes, sir.
Okay. There are two ways in which we can do this. Now, what are the two ways? We can pour all sand at once, or we can add 1 grain of sand at a time. Okay, 1 grain of sand at a time. अच्छा, एक बात बताइए सबसे पहले. Once you pour the complete sand down, ठीक है, ध्यान सुनिएगा. Once you completely pour that sand down, क्या इस change के बीच में, while you are pouring this down, yes, this is final, and this is initial, right? This is the change happening. This is the change happening. Here is the change happening. Okay, you took the complete thing and you poured all the sand down. And once you pour all the sand down, do you think you can change it? Can you stop the process in between while you are pouring it down? Tell me, guys. In between the change, can you go back to the initial state? Yes or no? Tell me. While pouring the complete thing down, can you go back to the initial state? Yes or no?
No.
No, right? That is an irreversible process. ध्यान रखिएगा, प्रोसेस irreversible है. आपने एक बार आपने डिसीजन ले लिया. Like once you took a decision that you are going to pour the complete thing down, in between you cannot change that. हाँ, अब लोग बोलते सर irreversible कैसे? सर बालू को हम हटा देंगे तो हो गया ना फिर से वही. Now that you are changing the state. Process is not irreversible still. Now the state is reversible यहाँ पे. The state is reversible, but the process was irreversible. So we are talking about change. We are talking about the process. Now in this process, when you pour all the sand down, it is going to be what? It is going to be irreversible. Irreversible process. ध्यान दीजिएगा, ये मत क्लास के बाद ये मत सोचने लगिएगा कि सर बालू हटा देंगे तो निकल जाएगा ना, इनिशियल स्टेट तो आ गया. नहीं, प्रोसेस के होते हुए आप चेंज कर सकते हैं. नहीं. But what about these small things? If I took a grain, if I put a grain here, है ना, if I put a grain, मेरा मूड बदल गया. अभी तक ये फाइन स्टेट में नहीं पहुंचा था, हम प्रोसेस के अंदर ही है ना. आई वेंट 1 grain, 2 grain, 3 grain, 4 grain, 4th grain के बाद लगा नहीं हमको वापस आना है, आई वांट टू गो बैक. तो फिर हम उल्टा चल सकते हैं, राइट? Yes or no? Please tell me, guys. I can go back now when I am doing this process, which is adding 1 grain at a time. Then in that case, what I can do? I can go back to the initial state. I can reverse the process also while the process is happening. So wait a second. No, I want to reverse the process. So this is a reversible process. This is a reversible process. अच्छा, एक और चीज आप बताइए. Irreversible process में अभी छोड़ दीजिए इसको. Reversible process के बारे में बताइए. If I add a grain here, if I add a grain, will there be any change in the pressure? Any significant change? Significant का मतलब होता है any measurable change होगा यहाँ पे, बताइए. If you add 1 grain on the piston, yes or no? Tell me, guys. Will there be any change?
No, sir.
No. I added 1 more grain. तो 1 grain और 2 grain के बीच में कोई change होगा? Tell me. Calculate the pressure here, है ना? And उसके बाद यहाँ पे आपने दूसरा grain डाल दिया. First grain और second grain में भी you will not see any considerable change. Similarly, third grain में भी नहीं. The change will be very, very slow, and that is why we say that on each change there will be equilibrium throughout the process, है ना? Because what is equilibrium? When the macroscopic properties, they do not change. What is the macroscopic property that we are going to look here? It is the pressure, or you can also say the volume. अब एक ग्रेन डालेगा तो थोड़ी ना नीचे जाएगा piston. It will not go down. That is why the volume will also not change. So we will say that in reversible process, equilibrium is maintained. Equilibrium is maintained at all steps. At all steps. Is this clear? Yes or no? Please tell me, guys. Is it clear, guys? Yes or no? Please tell me.
Yes, sir.
Please write this down now. After writing this, you will write this differences. Let me know if you need to understand any one of these things. If not, then please let me know. Write these points of a reversible process and reversible process. Devangi is asking, please, हाँ, ठीक है. Important one, देखिए. In this, there are gaseous molecules यहाँ पे inside the system, right? Inside this container, you have gas particles. ठीक है. अच्छा, इस piston का कुछ तो weight होगा, और वो piston नीचे क्यों नहीं जा रहा? Because these gas particles are going to exert a pressure here. राइट देवांगी, यस और नो?
यस सर।
ठीक है, और आपने डाला 1 ग्रेन ऑफ सॉल्ट, करेक्ट? ठीक है, अब एक तो कंप्लीट एटमोस्फेयर इज प्रोटिंग व्हाट 1 atm ऑफ प्रेशर, plus you added 1 grain of salt, and that grain of salt, due to its mass, it is going to put some pressure. ठीक है, अब ये बताइए, this force that is driving the change, क्योंकि आप देखिए अगर प्रेशर इंक्रीज करेगा तभी तो ये पिस्टन नीचे जाएगा. What is my driving force? Whatever this grain is putting now. Now this driving force, it is what it is, infinitesimally greater than the opposing force. That means infinite होता है क्या? Very large. Infinitesimally greater मतलब बहुत ही small, very very small, infinitely small. ठीक है, infinitesimally का मतलब क्या हो गया? Infinitely small. ठीक है, उतना ही आपका प्रेशर बढ़ेगा, greater than the opposing force. Opposing force क्या है आपका? The pressure that is given by the gaseous molecules. उससे थोड़ा ही सा ज्यादा होगा ना, right? It will be what? It will be what? थोड़ा सा ज्यादा क्या होगा आपका? थोड़ा सा ज्यादा होगा 1 ग्रेन ऑफ सॉल्ट डालने के बाद. Okay, so that is the driving force is only infinitesimally greater than opposing force at all stages. ठीक है, यहाँ पे क्या होता है? The driving force is different than the opposing force. अब अगर आप पूरा का पूरा क्यों completely pour the sand, then this force will be what? Very different from the opposing force. This is your opposing force, and the grain that you are putting, that is your driving force. Okay, so in the case of reversible, this driving force will be what? Very 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 small, थोड़ा सा ज्यादा होगा, right? So that is infinitesimally greater than the opposing force, and in irreversible case it will be very different. Clear है देवांगी?
यस सर।
रिवर्सिबल प्रोसेस जो हमने लिखा लास्ट में, दैट इट इज इमेजिनरी इन द सेंस दैट इसके लिए जो कंडीशंस हम लोग को देने पड़ेंगे, दैट इज गोइंग टू बी वेरी आइडियल कंडीशंस, है ना? और दोज आइडियल कंडीशंस सिर्फ थ्योरेटिकली पॉसिबल है, और हम लोग जो भी कैलकुलेशंस करते हैं वो आगे पीछे होता है, रिवर्सिबल मान के चलते हैं आइडियल सिस्टम. जैसे फॉर एग्जांपल इन फिजिक्स आल्सो यू मस्ट हैव लर्नड ना कि अगर इफ यू हैव अ बॉल दैट इज रोलिंग, आप जब तक आप लोगों ने फ्रिक्शन नहीं पढ़ा था तब तक आप मान के चलते थे कि यहाँ पे फ्रिक्शनलेस है, बट फ्रिक्शनलेस कोई सरफेस हो नहीं सकता है, राइट? यू कैन नॉट हैव एनी फ्रिक्शनलेस सरफेस. उसी तरह से रिवर्सिबल प्रोसेस कुछ हो नहीं सकता, बट आप मान के चलते हैं, एंड देन यू फिगर आउट व्हाट इज द अदर थिंग्स दैट यू आल्सो नीड टू फिगर, है ना? जैसे यहाँ पे फ्रिक्शन था, फ्रिक्शन को आपने जब फिगर आउट कर लिया तो फ्रिक्शन को इक्वेशन में डाल दें. लेट मी नो इफ यू आर डन गाइस. Please let me know if you're done. Still writing? Let me know if anyone is writing. Now, the next thing is, the next definition that we want to write is about energy. Okay, so some simple forms of energy that you must have learned in physics. Let's start with very simple one, that is a potential energy. And if you have a ball pen or some pen like this here, or some block of iron, something, and it is above the ground, then this is going to have some potential energy, right? It's going to have some potential energy. When it falls down, while falling down, it is having kinetic energy, and once it has fallen down, it is not going to have any potential energy. But there will be the molecules, if I zoom in, there will be molecules of this block which will be vibrating, right? Which will be vibrating, and this vibration will give it some kind of energy, right? And further on, what we can say, there will be inside electrons which will be moving. Those electrons will have some kinetic energy, some potential energy, because it is attracted towards the nucleus. So a body always have some kind of energy until and unless it is destroyed. Until and unless it is destroyed, it is going to have some kind of energy. And the sum of all of those forms of energy, it is known as internal energy. What we are having? We are having new term, that is internal energy. Internal energy, that is defined by that is denoted by U. And what is internal energy? Sum of all forms of energy stored in a system. ठीक है, अब देखिए फॉर एग्जाम्पल एक चीज बताते हैं. मान लीजिए इसमें ना कुछ भी एनर्जी नहीं होता, सिर्फ और सिर्फ पोटेंशियल एनर्जी होता. ओके, इट वाज ओनली पोटेंशियल एनर्जी. वी हैव अ फॉर्मूला टू कैलकुलेट पोटेंशियल एनर्जी दैट इज इक्वल टू mgh. ठीक है, मास इनटू ग्रेविटी इनटू हाइट. बट ये mgh से जो भी आपके पास मेजरमेंट्स आएंगे ना, दैट इज नॉट गोइंग टू बी द एक्यूरेट, एंड दैट इज आल्सो नॉट, बिकॉज आप देखिए जब ये पोटेंशियल एनर्जी mgh हम लोग ले रहे हैं, वी आर नॉट टॉकिंग अबाउट एयर रेजिस्टेंस. इज दैट राइट? यस और नो, प्लीज टेल मी. देयर विल बी सम रेजिस्टेंस बाय द एयर. Is that correct?
Yes, sir.
Right. We are not calculating about that as air resistance. That means अगर आप potential energy आप मान के चल रहे हैं, and if you write mgh, that means you say that I can extract this much energy from the substance here, which is at this height. है ना? Why it is important? See, you can know the original potential energy, or you can know the energy that can be extracted from a substance, that can be extracted from a body, from a system, only after you make it change. आपने potential energy यहाँ पे you had here, and then you measure the kinetic energy as it was falling down. Okay, and then the whatever kinetic energy you get, that is going to be the exact energy that you can derive from this particular system. So think about internal energy. अब ये तो potential energy ही exact नहीं था. You talk about the vibration inside this molecule. Then you talk about the electron that is revolving. And then you talk about the certain temperature it is going to have. And this temperature, because of this temperature, it is going to have some kind of energy. So it is impossible to measure all forms of energy in a particular system. And that is why it is impossible to measure the internal energy. Okay? It is impossible. It is impossible to measure all forms of energy, and hence it is impossible to measure absolute internal energy. It is impossible to measure absolute internal energy. So what do we measure? We measure the, अच्छा एक चीज यहाँ पे लिख लीजिए, U is equal to the potential energy plus the kinetic energy of the body plus the vibrational energy of the body plus what we can have translational plus rotational energy. ठीक है, इन सब पे अब इसमें से कुछ जीरो भी हो सकते हैं, and so on etc. ठीक है, it is the internal energy. Now what we can measure? We can measure the change in internal. For example, I am here, I don't know my internal energy. What is my internal energy? But I take one banana, or I eat some food. I will get certain kilocalories. I can get some calories of energy now. Okay. So what I can say, change in my internal energy is equal to this much. I can measure the change in internal energy. Then I go for a walk. I will spend some energy. Then again, I will say the change in the internal energy is this much. So what we can do, we can measure the changes in the internal energy, but we cannot measure the absolute internal energy. So what we can measure? Right, next. Rather, we measure. ये भी सिर्फ ना, ये फॉर्मूला नहीं है. देखिए, हर एक चीज जिसमें इक्वल टू लिखा रहता है, दैट इज नॉट अ फॉर्मूला. ठीक है, आप 11th क्लास से ये बहुत अच्छी चीज सीख के जाएंगे, that everything that is having an equation does not mean it is a formula. It is a, what is this? This is the definition of internal energy. है ना? अब यहाँ पे डेल्टा यू भी हम बताएंगे, what is change in internal energy. That is also going to have some equation, but that equation is not a formula जिससे आप calculate कर सकते. Please see right here. Rather, the change in internal energy can be measured. Change in internal energy can be measured. ठीक है? अच्छा, change in internal energy is the internal energy of final minus the internal energy of initial. ठीक है? Please ध्यान रखिए, again this is not a formula, this is just a definition. क्या definition है? Initial minus final करें या final minus initial, क्या होता है? Change in energy अगर हम बात करेंगे तो we are defining some set rules here. Because आप बताइए, ये जो हमने U final लिखा है, this is what? This is the absolute internal energy at final stage. और ये जो UI लिखा है हमने, this is the absolute internal energy at initial stage. At initial state. ठीक है? अभी तो हमने कहा कि absolute को define ही, absolute को measure ही नहीं कर सकते, right? So if we cannot measure the absolute, then why are we writing this? Because this is not a formula. This is what? This is a definition. Please remember this. This is not, ये आपको internal energy आपको निकालना होगा, आप ये इसको use ही नहीं कीजिएगा. You are not going to use it. Okay, you are not going to use it. Final minus initial. Delta U, it is equal to internal energy final minus internal energy initial. ठीक है? इससे क्या पता चल रहा है? इससे ये पता चल रहा है कि it depends only on the final and initial state. That is why internal energy is a state function. क्या है ये? Is a state function. अब थोड़ा सा हम लोग, like we can talk about the sign of internal energy. Let's suppose we are talking about us. अब एक केस ले लीजिए A, सालिम सर 8, हमने खाना खाया, तो डेल्टा यू क्या हो जाएगा बताइए? डेल्टा यू इज गोइंग टू बी, बताइए फाइनल स्टेट में क्या हो गया? खाना खाया तो हमने इंटरनल एनर्जी बढ़ गई. यस और नो? प्लीज टेल मी गाइस. यस और नो? तो डेल्टा यू क्या हो जाएगा? ज्यादा है, और इधर इंटरनल एनर्जी यहाँ पे इनिशियल में क्या थी? कम. तो डेल्टा यू विल बी पॉजिटिव. बी केस में सालिम सर टुक अ वॉक. अब यहाँ पे क्या होगी? मेरी एनर्जी तो कम हो जाएगी, राइट? माय फाइनल स्टेट विल बी व्हाट? विल बी हैविंग लेस एनर्जी, एंड दैट इज व्हाई द साइन विल बी व्हाट? टेल मी गाइस. डेल्टा यू का साइन क्या हो जाएगा? व्हाट विल बी द साइन ऑफ डेल्टा यू?
नेगेटिव.
नेगेटिव. ठीक है? तो हमारे पास डेल्टा यू की जो वैल्यू आएगी वो नेगेटिव में होगी. ओके? और डेल्टा यू की पॉजिटिव में कब होगी? जब आपने एनर्जी दिया सिस्टम को. सो व्हेन यू गिव्स एनर्जी टू द सिस्टम, द चेंज विल बी in positive, and if you take energy from the system, then what is going to happen? The change will be in negative side. Please write this down. ऐसे तो बॉडी की मतलब हमेशा कुछ ना कुछ वो एनर्जी यूज करते ही रहता है. तो मान लीजिए आपके पास व्हेन डेल्टा यू इज इक्वल टू 0, तब आपके पास कोई चेंज नहीं हो रहा. दैट मीन्स U final is equal to U initial. ठीक है? प्रोडक्ट और रिएक्टेंट के केस में ही बात कर सकते हैं हम लोग. ठीक है? यहाँ पे, बट वी आर नॉट टॉकिंग अबाउट ओनली द फाइनल एंड इनिशियल स्टेट्स. प्लीज राइट दिस डाउन and let me know if you're done. Right, next, modes of transfer of energy. Modes of transfer of energy. But उससे पहले ना आप समझिएगा कि there are two modes of transfer of energy, और एक चीज को आप हमेशा एनर्जी मान के आ रहे थे. That is not exactly energy. That is a mode of transfer of energy. That is not exactly energy. ठीक है, नाउ प्लीज सी, आई एम टेकिंग अ केस। अच्छा, वो पिस्टन हमने बनाया था ना, पिस्टन को लेके आते हैं यहाँ पे। टेक दिस कंटेनर एंड द पिस्टन दैट इज with the container. Move here, and yeah, I need one more. Okay, and we don't need the sand here. We don't need the sand here. So we have these two cases. अब यहाँ पे हमको दोनों में क्या करना ना, I have to lift this piston up. What I need to do? I need to lift this piston up. So there are two ways in which I can lift the piston up. First of all, देखिए, what I can do, I can get a burner here. ठीक है, I can get a burner here, and I can inflame this burner, and I can heat it up. When I am going to heat it up, what is going to happen? This molecules here, they are going to start moving very rapidly. And once they start moving rapidly, they are going to increase the pressure inside here. And they are going to put pressure on this piston, making it move upwards. So दूसरी चीज क्या कर सकते हैं? I can just hold it and I can pull it up. Yes or no? Please tell me, guys. Correct?
Yes, sir.
ठीक है. So there are two processes. I can either heat it up, ठीक है, जिससे आपके पास चेंज आएगा. Or what else we can do? I can pull it up, and when I am going to pull it, I will apply force. And whenever I apply a force and there is a distance traveled, we say that work is done. Okay, so there are only two modes of transfer of energy. Heat आपकी energy नहीं होती है. Heat is what? Heat is the transfer, mode of transfer of energy. What do we have? We have two different modes of transfer. Please write. Modes of transfer of energy. Modes of transfer of energy, right? The first one, heat, that is equal to, written by Q. Okay, so when you are heating surrounding the system, please write, if you add heat to system, तब क्या होगा? Q को हम लोग बोलेंगे पॉजिटिव. ठीक है, Q will be what? It will be positive. And when you take heat from the system, in that case Q will be negative. ठीक है, सिस्टम से सराउंडिंग अगर जा रहा है, अगर यहाँ पे आपके पास क्या हो रहा है, सराउंडिंग से हीट सिस्टम की तरफ जा रहा है, एंड इन दिस केस सिस्टम से हीट सराउंडिंग की तरफ जा रहा है. ओके, कीप दिस थिंग्स इन योर माइंड. नेक्स्ट केस है आपके पास वर्क. वर्क इज अनदर मोड ऑफ ट्रांसफर ऑफ एनर्जी. इफ यू डू वर्क ऑन सिस्टम, वर्क डन ऑन सिस्टम, तब यहाँ पे क्या होगा? W will be, it will be a positive number. And if work is done by the system, W is going to be negative. Okay, and this gives us the first law of thermodynamics. हाँ, फिजिक्स में सिस्टम ही क्या है वही तो आप डिफाइन कीजिए पहले. फिजिक्स में उल्टा है. अरे फिजिक्स में ना वो इंसान को लेके चलते हैं. ठीक है, बात फिजिक्स में आपने सिस्टम को डिफाइन किया था, ये बताइए. वहां पे पढ़ा था आपने सिस्टम क्या होता है?
याद नहीं.
हाँ, है फिजिक्स में
याद
डेफिनेशन? नहीं याद, हाँ वो है ही नहीं. ठीक है, वो इंसान को लेके चलते हैं. ठीक है, तो हम अगर कहीं पे काम करेंगे, ठीक है, इफ आई डू, तो इंसान की तो एनर्जी जा रही है ना, राइट, ह्यूमन की एनर्जी क्या हो रही है, जा रही है, इस वजह से वो नेगेटिव है। तो फिजिक्स के पर्सपेक्टिव से वो लोग इंसान को देख रहे हैं। सराउंडिंग में कौन काम करेगा, आग कौन लगा रहा है, वहां बर्नर जो हमने लगाया, तो बर्नर किसने लगाया, इंसान ने लगाया, इंसान की एनर्जी क्या हो रही थी वहां पे, एनर्जी उस टाइम स्पेंड हो रही थी। अब वही हम बोले थे स्टार्टिंग के केस में, फ्रेम ऑफ रेफरेंस का डिफरेंस है फिर, गॉट इट,
Okay.
ओके। फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, फ्लॉट, एब्रीविएशन में फ्लॉट बोलते हैं। फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या है, इट टॉक्स अबाउट द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। It says that the whatever change in internal energy you are seeing, it will be either due to the heat or due to the work done. It will be either due to heat or work done. Please write this down. यानी कि अगर आपके पास आइसोलेटेड सिस्टम होगा, तब उस टाइम क्या होगा, इफ यू हैव आइसोलेटेड सिस्टम, दैट मींस यू कैन नॉट, there is no exchange of heat, or there is, I mean, you cannot have any exchange of heat or work done there. So you will write, in isolated system, in isolated system, the energy of system is constant. All of you done? Yes or no? Please tell me. So read this question and tell me the answers. Okay. ध्यान से पढ़िएगा। पहले इसमें क्या बोला है? It is saying express the change in internal energy. आपको बताना है डेल्टा यू किस पे डिपेंड करेगा, and whether it will be minus or plus. For example, फर्स्ट में इन्होंने लिखा है डेल्टा यू इज इक्वल टू, आपको हमेशा याद रखना है, क्यू प्लस डब्ल्यू। ठीक है, हीट अगर आप दे रहे हैं तो पॉजिटिव, हीट अगर निकल रहा है यहाँ से तो नेगेटिव, वर्क अगर आप दे रहे हैं तो इट विल बी पॉजिटिव, वर्क अगर निकल रहा है तो इट विल बी नेगेटिव। ठीक है, फर्स्ट केस देखिए, नो हीट इज एब्सॉर्ब्ड बाय द सिस्टम फ्रॉम द सराउंडिंग बट वर्क इज डन ऑन द सिस्टम। ठीक है, दैट मीन्स डेल्टा यू इज इक्वल टू क्यू की वैल्यू 0 एंड वर्क इज डन ऑन द सिस्टम, तो प्लस डब्ल्यू, राइट? यस और नो, प्लीज टेल मी गाइस, इज दैट राइट? यस और नो? करेक्ट है। तो डेल्टा यू को क्या लिखिएगा आप, इट विल बी इक्वल टू प्लस डब्ल्यू। एंड व्हाट टाइप ऑफ वॉल डज इट हैव? देयर इज नो हीट अब्सॉर्ब, दैट मींस इट इज गोइंग टू बी adiabatic wall, adiabatic boundary. Please try to do for the second and the third case. प्लस और माइनस साइन में बताइएगा डेल्टा यू का क्या होगा, एंड देन आल्सो टेल मी अबाउट द वॉल, व्हाट टाइप ऑफ वॉल इज प्रेजेंट। Fahad has answered for 1. Please send the answer, then एक बार ही check करेंगे. यहाँ पे दूसरी चीज फहद, उन्होंने ना बोला है कि वॉल कौन सा होगा, आपने शायद प्रोसेस का नाम दे दिया. व्हाट टाइप ऑफ वॉल? ओके, व्हाट टाइप ऑफ, थर्ड में है सिस्टम. व्हाट टाइप ऑफ सिस्टम वुड इट बी? हाँ, थर्ड में सिस्टम है. हाँ, ठीक है. सेकंड वन में नो, दैट इज रॉन्ग. तारीफ, नो वर्क इज डन बट हीट इज टेकन आउट ऑफ द सिस्टम. देखिए, हीट टेकन आउट, हीट का एक्सचेंज हो रहा है, तो कौन सा सिस्टम, कौन सा वॉल होगा वहां पे? ट्राई टू थिंक इन दोस टर्म्स. ये बी के लिए है ना? हाँ, ठीक है, करेक्ट है एरम. डेल्टा यू की वैल्यू तो सही है. एंड टेल मी व्हाट टाइप ऑफ वॉल इट विल हैव. बी में व्हाट टाइप ऑफ वॉल इट विल हैव? सी में आपके पास क्या है? सप्लाई टू द सिस्टम. हाँ, दैट इज आल्सो करेक्ट एरम. टाइप ऑफ वॉल्स में देखिए, एंड दिस इज सेकंड में आपके पास टाइप ऑफ सिस्टम कौन सा होगा? ओके एरम, सी का आपने बताया है. चलिए, सेकंड में देखिए. सेकंड में डेल्टा यू इज इक्वल टू no work is done but q amount of heat is taken out of the system. That means it will be minus q plus 0, सिर्फ minus q हो जाएगा. And if there is a change of heat, that means there is a diathermic wall. There is what kind of wall? There is a diathermic kind of wall. Then what do we have here? Third case में आपके पास है W amount of work is done by the system and Q amount of heat is supplied to the system. तो यहाँ पे आपके पास डेल्टा U, work done by the system, that means it is going to be what? Minus W, or heat is Q is supplied to the system. So Q will be positive and work will be minus W. Please say this. ठीक है, तो यहाँ पे क्या हो रहा है? heat is supplied to the system and work is done by the system. So it is going to be, अगर आपके पास ओपन सिस्टम होगा ना तो हीट निकल जाएगी बाहर, अगर आप हीट सप्लाई कर रहे हैं तो. इट इज ऑब्वियसली गोइंग टू बी व्हाट? क्लोज्ड सिस्टम हियर, because you are supplying heat, and in order to preserve that heat, what you need to have closed system, not open system. Please write this down. After this you write a question. ये कैलकुलेट करने के लिए है. You use the formula delta U is equal to Q plus W. ठीक है, but keep in mind the sign of Q and W's. Write this down. Send the answers on Zoom chat itself. ठीक है, बस बहुत आसान है आप लोगों के लिए करने की. ठीक है, सोल्यूशन में देखिए. Right, in the first case, Q is equal to absorbed है तो क्या होगा? Plus, और if it is going away, then it will be minus. Q कितना है? पॉजिटिव नेगेटिव साइन के साथ नंबर्स दिए हुए, साइन आपको बस ये करना है. ठीक है, सेकंड केस में भी है, और उसके बाद इन दोनों को बस यहाँ पे मतलब प्लस माइनस करके जोड़ दीजिए. सेकंड इज सेम, Q is equal to this much, W is equal to this much, including the signs, and then इन दोनों को सम कर दीजिए बस. So you see what I have answers. Devangi and Hiba have answered the same thing, so I think it is correct. Yeah. Yes, I think you guys are answering it correctly. आसान सवाल है ये सारे तो. ठीक है. जानिया, आपका आपका आंसर आता ही नहीं है. जानिया, प्लीज आंसर. जानिया, if you have problems, please let me know. Okay, Devangi and Hiba, those answers are right. I mean that this is the end of the class. You can leave the class. Okay, and in the next class we will talk about a bit more about the irreversible and reversible process, और उसमें हम थोड़ा सा change देखेंगे. Okay, so please come on Thursday. Okay, Iram, yours also is correct. You can also leave.
Thank you, sir.
Okay, thank you. Thank you. Bye bye. Jania waiting for you. Tarif waiting for you.
Yes, sir.
Tarif. Tarif, you stay. Jania, Tarif, and Fahad send the answers, and then only you can leave. And if you're stuck, please let me know. Yes, Jania, what happened? Also, Fahad, आप आंसर भेजिए. हाँ, तो उन दोनों को ऐड कीजिए ना. जानिया, जानिया, कैन यू प्लीज टर्न योर माइक ऑन? जानिया,
Yes, sir.
इंटरनल एनर्जी कैलकुलेट करना है ना. अब पूरा पूरा चीज नहीं कीजिएगा, आधा हम करें। डेल्टा यू क्या होगा? डेल्टा यू इज इक्वल टू जो क्यू की वैल्यू है आपके पास प्लस जो आपके पास डब्ल्यू की वैल्यू है। कितना आएगा उन दोनों को ऐड करने पे, बताइए। क्या है? क्यू आपका 428 है प्लस
714।